Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to discuss about AC coupling and DC coupling system. So this is the very important chapter about in solar PV system. We are going to discuss about how we are going to store the energy in the battery. So we know that battery can be connected in the on-grid system as well as off-grid system. Now there's a question people always ask that how are you going to connect the battery? So what methods you are going to connect the battery? So this is also answering some of your doubts that why some students ask and some people ask doubt that why we are charging the battery, then we take the power from battery like charging, discharging even in the daytime, because their question is that instead of sending the power to solar electricity generated by solar PV to the battery, why don't you send directly to inverter? Because in the DC coupling system, we are sending the power to the battery, then from the battery, we are taking to the inverter. So there's a loss because obviously there's a loss. If we charge and discharge, there's a loss. So the question is reasonable. You're asking like why we unwantedly charging and discharging. So so those questions will be answered in this lesson. So let's go to this the slides. So AC or DC coupling refer to the how solar panels are coupled or linked to a battery system. Okay. So as I said, it's about we are going to talk about how it's linked to the batteries. So this video going to take a little more time because I can't put like 5 minutes video to explain a deep concept, because we need to discuss a lot, because then only it will come to the end. Okay. So most electronic circuits are DC. The problem is we have a AC and DC. We need both. So here is a trick. Here's a trick. Instead of saying trick, here is a challenge. What our challenge is that most electronic equipments are DC. Solar panels produce DC current. Batteries can only store DC current. But our house appliances want AC current. Our grid is AC. So, in this renewable based power generation, let's say solar PV based power power system, we have a battery, solar PV, and the grid. So, this is a power system. Here, we have AC and DC both has a role. That's the problem, because as I said, the grid is AC, our house is AC, alternating current, but the solar panels producing DC current and the battery can only store DC current. So again, what is the problem here mean? If you want to charge the battery, you have to give a DC current. If you want to supply your household appliances like cooking appliances, you have to supply this AC current. So that is a problem. So let's look at AC coupling system. So this is a very simple, very nice diagram here. So if you look at this diagram, AC coupling system means whatever solar panels produce, you forget about anything else. You convert it into AC. This is a rule. You have a solar inverter. This is called solar inverter. Because why we call solar inverter? This job is to convert all the power generated by solar PV to AC. Okay, this is a DC power coming from the solar PV and converted to AC. So this is the primary first step. Then you can talk about rest of the things. So easy to remember for students. AC coupling means you forget about everything. You convert all the solar PV energy into DC power, DC energy into AC. Okay. So whatever coming from solar PV, you just convert into AC using the inverter. So this method is a AC coupling. After that, now we got AC power. This AC power come to the switchboard and feed it into the house. This is come to the house. Okay. If you have a excess power, that goes to the another inverter, that's called multi-mode inverter or hybrid inverter. Here is another story comes here. Another technical things coming here. So we have another inverter that again convert into DC current to charge the battery, because the idea here is if you have excess power, only the excess energy going to charge the battery. Okay, we supply to the house first. So house is our priority. We want this design, supplying to power to the house is my priority. So I did that part. So I put the dotted line. Okay, I have a solar PV system. I did the primary objective. Primary objective is to supply power to the house. Is done. Now I have excess power. Okay, this power I am going to store in a battery. But I have AC power. Now I have AC power. It's excess. So I want to store in a battery. How can I do that? I need to convert into a DC power. So we are using an inverter here. Okay, to convert into DC power and store in a battery. Then why we need a hybrid inverter, multi-mode inverter here? Because look at here, grid. We can charge the battery by grid as well. Because this inverter, I'm going to use a smart inverter, a hybrid inverter that can use uh, the power from solar PV to charge the battery, and also power from grid to charge the battery. And that is one of the reasons. Another important reason why we need a hybrid inverter mean, let's say we have a power shutdown. So there is no grid. Okay, I'll cross the grid. We don't have grid for today. Entire day we have a power cut. Now let's say today we have a little bit of the rainy or the cloud. So little bit of cloudy. So I don't have a solar PV as well. Now I have only battery. Battery is almost fully charged because yesterday was a good day. We got a lot of energy, so we charged the battery. Now my house is going to use the store energy from the battery to supply the power during daytime. So daytime or nighttime, whatever. So now again, this battery DC energy has to come to the house. How it can come? Through the inverter. This inverter now going to do the conversion of DC to AC. That's why we need a hybrid inverter. Now we explain the concept of hybrid inverter as well. So why need a smart and a hybrid inverter? Hybrid inverter itself, most of the hybrid inverters are smart inverters. Smart inverters mean we can do multiple functions. Okay, basically hybrid inverter means it can convert AC to DC or DC to AC. This is converting AC to DC in this path because to store the power in the battery. Okay, and it converting DC to AC in this path because to supply power to the house from the battery. Okay, it's simple. So we definitely need a hybrid inverter. Hybrid inverter which can convert AC to DC, and also it can convert DC to AC depend on the requirement, depend on the time requirement. And also we are using a kind of smart inverter that can take two inputs. Sometimes we need to charge the battery by both way. We want to use a grid supply because grid is during the off-peak hours, grid power is cheap. So whenever it's grid power is cheap, I want to use that cheapest energy to charge the battery, as well as the excess power from the solar PV to charge the battery. So this hybrid multi-mode smart inverter can do a multiple function. It can use two inputs to charge the battery. One input from solar PV. This path it's coming excess, whatever excess coming from here after supplying to the load, and what is coming from here. Okay, so this is a important discussion. I take a lot of time because then only you can clearly understand the concept. It may take a lot of time, this video. Don't worry, please bear with me. So again, you can ask a question, why we need two inverters? So that question I clearly answered. It seems to be the best of having two inverter, but this is the way we are installing, because logically you can understand why we need two inverters. Okay, now what is the loss here? Because the conversion we are converting three times. Okay, from the panel to the, this is your panel, this is your battery. Look at the battery at the end. It means from the panel DC converted to AC, then supply to the house, then AC converted to DC, then store in the battery. Okay, so two conversion is happening. Now look at, if you want the supply battery, the supply from the battery to house. Okay, I mean uh, during the power cut time, grid not available. Now there's three conversion. Uh, the actually the solar PV, and let's assume the scenario like solar PV and battery together has to supply the power. Grid is not available. Solar PV is generating little bit of power, but that is not enough to supply the house. Now what is the scenario? Solar PV and battery together going to supply power to house. So solar PV converting here and coming to the house, and battery again converting DC to AC by this hybrid inverter and coming to house. So this all possible by a AC coupled system. Okay. Okay. So DC power which flow into an inverter and is converted to AC to power appliances. So I highlight here in yellow color the important things. Let's read further. So AC coupled systems are often used for large scale off-grid system and use a common string solar inverter coupled with a multiple mode inverter. Multi-mode inverter also called as hybrid inverter. Okay. Uh, it's slightly less efficient. Why we are saying less efficient, 90 to 94%? Because we are not directly charging the battery using the solar panels. Okay. So compared to DC couple, I will explain what is my DC couple. We are not charging after going to a lot of conversion. Okay, so the charging efficiency is less. Okay, but more efficient for powering AC loads. Okay, let's say you're installing solar panels for the factory in Sri Lanka or any countries. So usually in our countries the factories are operating in the daytime. Usually in the daytime. So what happens in the daytime? You have lots of demand. Okay, so supplying to your demand, factory demand is primary purpose for solar panels. Okay, so the solar panels primary purpose is to supplying the house or factory demand. Then this AC coupling is more suitable because AC coupling, the AC coupling system, solar panels are directly energy from the solar panels are directly converted to the AC and supplied to the house. Simple. Okay, storage is a second. If you have excess power, we are storing after again using the hybrid inverter. So if you look at other type, we'll look at later in DC coupling. DC coupling we are directly storing in the battery. From the battery we are taking and supplying to the house. Here we are not. We are just directly. I mean in the daytime. Let's assume we have very good sun radiation, solar radiation in the daytime today, and our factory is running a lot of heavy induction machine, motors, chillers, heat exchangers, a lot of power consumption. So my solar panels directly supplying power to the factory. So it's more efficient. We are not storing energy because today the factory consuming a lot of energy, so I'm not storing it. Storing in the battery, I'm supplying to the load. Okay, so that is more efficient. Okay, so AC coupled system all converted to AC by inverter. It's useful powering appliances feeding to the main grid. Another best application. One application I said, not application, where it's most suitable. Okay, where it is most suitable. Okay, then another reason. Let's say you are installing a huge 30 kilowatt system in your house, but your house is consuming only, let's say, 1 kilowatt, 2 kilowatts, a very simple house. Okay, your consumption is very low. Now your target is to sell the power to the grid and get the money. The profit making is your target. Then why we want to store in the battery and then again convert into uh, AC? So in this case, so AC coupling is best because you directly convert whatever solar power is generated into from AC DC power to AC and supply to the grid. So directly the transaction is very easy. You are converting all your solar power to AC by an inverter and supply back to grid, selling to grid. You're selling to grid. So if your purpose is to make money, so selling, exporting is your primary purpose, then this is a good way. AC coupling is more suitable. Okay. Okay. So look at this diagram. Again, I put a lot of diagram because then only people will be convinced. But we are talking because we always have a lot of doubts. We have clarification. So through the diagram, through the pictures, we convince with the concept because it's quite a, difficult or the concept to discuss. Okay. So here the solar inverter. We have a solar inverter. Everything, every power converted to AC. Now AC here, there are two players. One is a grid, one is a house. Either you can set it to here. We have a supply. Supply comes here. This AC power you can send it to grid, or you can supply to house. Okay. And also, sometimes if you do not have any power during the rainy season, cloudy season, the grid will supply to the house. This is a transaction. The transaction, AC transaction is happening over here. Okay, it's clear. Now, again, if you have excess after doing all this AC transaction, the supplying to house or selling the grid, all the decision is made. If you still make a decision to store in the battery, then the power coming to the battery inverter. This is called battery inverter. This battery inverter convert into DC power and store in the battery. This is your battery. Okay, this is the battery. Okay, so this is the AC coupling system. So you can simply imagine the storing in the battery is the last option, the least priority. Okay, simple. So you can understand the application of storing in the battery is the least priority. So is mostly suitable for the on-grid system. So some let's say people with a lot of money, they say like install the solar PV system and also install a small battery. I have a good grid. I don't have a problem with the grid. So I have a on-grid system. So if you have a on-grid system, you don't have a problem with the grid. I mean, problem means the power cut, the not frequent power cut. You don't need battery. Simply, you don't want battery. But people with a lot of money, they say, better to install a battery. I want to store excess power from the solar PV. For those options, the AC coupling is more suitable because we have a grid. Grid will play the major role here in this area. If you still have excess after doing all these things, export, import, you still have excess, you can uh, store in the battery. So this is the most efficient for the AC coupled system. And AC coupling using solar inverter is far more efficient for grid tie storage, energy storage system, especially when daytime loads are very high. As I said, for the factories or any industries, daytime loads are very high. When the daytime loads are very high, it's better to have a AC couple system. I think we'll finish the AC couple and we can talk about DC couple in a separate video. So we come to the end of this video because earlier I talked to teach you AC coupling and DC coupling together, but it take more than half an hour. So I stop here and you can watch DC coupling as a separate video. So please subscribe this channel. So by doing that, you can encourage me so that I can discuss these kind of things. I always say that when you read in the books, you can't really get all sort of these kind of discussion. I mean, some people can understand from the writings or reading books. It's always advisable to read the books, but you need to get a little bit of understanding by discussion. This is why we call teaching. You get a general understanding, then go and read the book. You will get a deep understanding about all these power system, renewable energy, solar PVs, and later I will teach you on mathematics. Okay, thank you. Please subscribe this channel.